Hi there, welcome back. This is Middle School Math with Dr. Koenig. I'm glad you're here. Today we're going to talk about how to find the slope from the graph of a line. Let's jump right in. So there are three significant ways you can find the slope of a line of a linear relationship. You can do so from a table of values, and you can do so from 2 points on that line. There's a slope equation. You can also do so on a graph. Obviously here we're talking about finding the slope from a graph. But if you need help with the other two, I have videos on each of these three major ways to find the slope of a line, and I welcome you to watch these videos and check it out. I will drop the links here so that you have them. Otherwise, this video right here is going to focus on finding the slope from a graph. So here we have a line, the pink line in front of you, and we're looking to find the slope of it using a graph. Now it's important to remember what the slope tells you. The slope tells you how much the y value changes for each change in x. The more the y value changes, the steeper the line, the higher the slope. Essentially, it all comes down to how much y is changing compared to how much x is changing. We often see that as change in y compared to change in x. You might see that abbreviated one of two ways. Sometimes you see it delta y over delta x. That's a very mathematical way to write it using symbols. The delta just means we're looking for that change in y and the change in x, and we're comparing the two using a fraction. You might also have heard it called rise over run. And that's what we're going to really talk about today is rise over run. Because when you're on a graph, looking for how much it rises and how much it runs is essentially how you find the slope. Now in this case, my rise is how much from one point to the next my line is increasing. And then my run tells me how much it's moving over in that time. To calculate the value of the slope, I need to know how much my line has risen for that one value of x. I can clearly see it's only moved over 1 on the x-axis, but I can see 1, 2, 3, 4, 5, 6. It has increased by 6 on the y-axis. That tells me that my rise over run, or my slope, would be 6 over 1, which is equal to 6. All right, here's another line we're going to take a look at. Again, we're going to think of this as rise over run, not because that's a very mathematical or technical way to talk about the slope, but it is a nice way to visualize what's happening on a graph. So rise over run would be the same as being more technical, change in y over change in x, or delta y over delta x. Regardless, we're looking for a fraction. We want to go from one point to the next, and we want to see how much our line is increasing and then how much it's moving over, because we need to know how much the y value is changing compared to the change in x value. Now I can see that my y value is increasing by 2, and I can see that my x value is increasing by 4, and I would write that as rise over run, which is 2 over 4, which simplifies to 1/2. Now that's a much smaller slope than the last one we looked at, which was 6. So you should notice that this is a little bit of a flatter line. The line that had a slope of 6 was pretty steep. What's interesting about finding the slope is that you can use any 2 points on the line. I clearly outlined 2 points here for you. However, I can see that the line also crosses through this point. I can see that the line also crosses through this point. And if I look for my rise and my run, I can see it increases 1 on the y-axis for every 2 on the x-axis. Those points would also give us a slope of 1/2. And that's important information about a linear relationship. If it's truly linear, the slope should be consistent. It should be the same no matter which 2 points you use. Here's another example. This one really looks quite a bit flatter than the other two. So what that tells me is I'm probably going to get a smaller slope, definitely a smaller slope than 6, but it also looks smaller than the example we just did that had a slope of 1/2. So I'll probably get a smaller slope than that too. Now, I'm looking for my rise and my run, and I always do that on a graph by drawing these lines. I kind of call it a road map. How do I get from one point to the next? So I draw the lines. We need one that goes up and one that goes over. Sometimes it'll be down and over, and we'll see an example of that. In this case, it goes up and over. I can see that it goes up 2. It's a little harder to see how much it's moving over, so it helps to count those out. See that it's going over 8. Going back to rise over run, I can see my rise is 2, my run is 8, which gives me a slope of 1/4. Now remember, you can use any points the line crosses through to find that 1/4, and it should be consistent. So for example, I see that my line also crosses through a point over here. And if I look for rise over run, if I draw my road map, I can still see that it's increasing 1. And in this case, my run is still 4. So I would get a slope of 1/4. Here's another. What you should immediately be noticing is that this line is decreasing, it's going down, and that's going to change how we draw our road map, and that's going to change the slope that we find. So I'm still looking for rise over run. However, I'm noticing that this time it goes down, so that's going to change what my slope is. When I draw my road map, I always want to go up or down first, so I'm going to go down and over. I can clearly see that my run is going to be 2, but I need to count out my rise. I see that that's decreasing by 6, so I'll write that as -6. Now going back to rise over run, I have found -6 and 2, which simplifies to -3. All right, those are 3 really brief examples, but hopefully finding the slope on a graph is relatively easy for you. Essentially, we're looking for how much y is changing, and we're comparing it to how much x is changing, the same way we would if we were using a table or if we were given 2 points on that line. Some people remember that as change in y over change in x. A shortcut way, something that's a little easier to remember, is rise over run, and that's a way that a lot of young mathematicians will focus on slope as rise over run when they're using a graph. It can be really helpful for finding that slope. So thanks for being here. If you need more help finding slope, remember that I have 2 other video tutorials, one on finding the slope given a table of values and one on finding the slope given 2 points on the line and using what we call a slope formula. So if you want to check those out, I will drop them for you here at the end of the video. Otherwise, thanks for being here, and I'll see you next time.